Hello, and welcome to 5-Minute Math. Today we are looking at representing an unknown quantity. This is 4.58 Readiness Practice, the intermediate version. If you're interested in exploring the 4.58 Readiness Practice for the proficient or advanced versions, or for looking for Readiness Practice resources aligned with any other standard, you can find those by using the link in the video description. So we have a pretty basic setup here with a farmer packing oranges into baskets. So let's draw what we have here. 3 baskets packed with 10 oranges each. All right, so let's make those orange. And I'm just going to draw a strip diagram here because I'm going to need to draw a strip diagram as part of my solution. So I'm going to make 3 baskets, 10 oranges each. All right, so hopefully we see that and we're automatically thinking, all right, so that's 30. Good. Now I've got 2 baskets. I've got an unknown quantity, so I don't know how much is in there. We're going to represent that unknown quantity rather than a question mark. We're going to represent it with the letter X. I've got 2 baskets of apples that are X, and all together, so if we were to put all of this together, like the apples and the oranges, we've got 48. Now, draw a strip diagram and write an equation to show X, how many apples are in each basket. All right, so I've got my strip diagram, and what I could do is I can also write it as an equation. All right, so I can say 48 is my total equals, well, what I have is I have 30 oranges, but it's really 3 times 10. So you can show 3 times 10 multiple ways. You can do 3.10. You can do 3 and then parentheses 10. There's a few different ways to show it. We don't really want to do 3x10 because the x can mean a multiplication or the letter x, which is our unknown number of apples. So we really move away from using an x for multiplication. So if I were to take my 3 times 10 and then add that with my 2 x's, 2 times x, right, that's going to get me my 48. So that's an equation that I could use as well. And we're not even actually solving, but we could go ahead and solve if we want to. It doesn't ask us how many apples there are. We just need to draw a strip diagram, write an equation, which we did. Think about this. If I've got 48 total, and I've already used 30 for my oranges, that means that I've only got 18 left, because 48, right, minus 30 equals 18. Now, my 18 is split into 2 equal groups, x and x. So really, if I want to think about it, I could also think, all right, so my x is going to equal 9, because I've got 9 and 9, that makes 18. That 18 plus the 3 sets of 10 make my 48 total. So this over here is just kind of bonus. We didn't really need to do this, but this is eventually what we're going to need to do in middle school is solve for x. Right now, we're just drawing representations and equations that represent how we can eventually solve for x. So for our second problem, we've got Maria. She had 12 stickers. She gave 5 to her friend. Then she bought 6 more. So how many stickers does she have now? We need a strip diagram and an equation. Okay, so we're looking for S, how many stickers she has now. Okay, so let's draw this. We had 12 stickers. That's how many she has to begin with. And she gives 5 away. Okay? And so what I'm going to do is I'm going to take a second bar down here, and I'm just going to say we're going to take 5 away. We're going to subtract that 5. Then she buys 8 more. Well, my top bar is going to be how much I'm adding. So I'm going to add this 8 more up to the top. So the problem tells me that I have 12, then I take away 5, and then I add or buy 8 more. But you don't have to necessarily do it in that order. You can add the 12 and the 8, and then subtract the 5 if you want to. So that's our strip diagram. And our S is how much she has remaining. So that's going to be that missing space in the bottom bar is how much she has remaining. Okay. We can also write S, and then we could do it exactly like they told us to do it. You start with 12. You subtract 5, so that gets you 7. And then you add 8 right? And then, so that's going to get you 15. Or, if you wanted to, you could have the 12 plus 8 is 20, subtract the 5, that gets you 15. Okay, so we could, if we want to, as a bonus, we could simplify that and we can say S equals 15. We don't necessarily need to, but like I said, some of us are ready for that. We're going to get to that eventually. All right, so for our third problem, we have Amy. She's got 25 apples. She gives 12 to her friend, then buys 15 more. And so this is going to be a similar setup to the previous problem. So she has 25 apples. The numbers are just a little bit bigger. So let's make a little bit bigger bar. 25 apples. She's going to give 12 to her friend. So that's going to be about half. Let's do that. And then she buys 15 more. So let's make an additional bar up on the top. And then how many apples does she have now? And we're going to put that right here. That's going to be our X. How many she has now. So we can say X equals 25. I'm going to go ahead and reverse this. If I really wanted to solve this, I would probably do the 25 plus 15. Okay. We can use the commutative property of addition to rearrange addition and subtraction items. Okay, so 25 plus the 15 minus the 12, which means 40 minus 12, which means if we really want to, we can solve that as X equals 28. But that's, once again, an extra one. Your equation might be slightly different. You could also just do it in order. X equals 25 minus 12 plus 15. Either of those work. So this is the 4.5a Readiness Practice Intermediate. If you're interested in exploring the proficient and advanced versions of 4.5a or the Readiness Practice resources aligned with any other standard, you can find those by using the link in the video description.